Hi there, and welcome back to the stream. I'm Junshan, and today we're working again on the Chronofold data structure. And last time we did a few things related to testing, and today's stream is going to be fairly short, and I want to try and move forward a bit. Since the last stream, I just was trying to refactor the this append string function here, and so let's give that a shot. And I think I went a little bit too far in the good old refactoring, and I just realized that because I restarted my VS Code, it dropped my undo buffer, and I haven't been having any Git discipline at all. So maybe we'll change that as well, and maybe do a first commit and push this online. That would maybe be a nice thing to do. But that means that I'm a little bit embarrassed here with my refactoring, which let's see, was I think something like this, and I was just appending, whoopsie, not that. I was just appending to the log the op. Let's just double check that it still works, and we can remove this for the shadowing warning and properly parenthesize. And okay, I think this builds and rebuilds. Yeah, okay. That's fine. And so I gather this indeed doesn't depend on... I wanted to try and separate append op from build op. And I suppose that's possible. I'm just... so build op will need to be this, and that's the warning about shadowing, and therefore, okay, let's try a build up prime here and do this progressively. Would be what? Would be build up, and I was thinking that it would be, oh well, maybe I wasn't parenthesizing this correctly. And right, so here we need to close over this. Would it be fine? Could not match code point to op. Okay, build up prime. Well, that's not going to change this, but so append op takes a log, which we give in it, and an op, and build up takes a log, and I mean fold L means that build up prime going to give it the log and an A, which is a code point, right? And that's what we want. We want a log and a code point to be passed. So there's something going on there with the passing of, like, it's, I think I need to use uncurry or something. So let's see. I think if doing this 0.3 is actually not super easy. So maybe I should just do it 0.4, which I think is here, is this. And L was shadowed, okay. R prime. Okay, that seems to be the way, and therefore I can do what? I can replace this by a lambda. So lambda L prime C and return then I think I didn't use the I didn't cut properly. Okay, actually, probably this is the smartest way to copy paste this and backslash this, and then arrow. Yeah, still builds, not the prettiest. Let's make sure about our L's and our L primes here, because L prime's the accumulator. And we start with L. So we're not depending to L, we're really depending to L prime. Where these tests shouldn't pass, and they don't pass. Excellent. So I guess I can still think about my code, which is fantastic. And I suppose this should address it. Well, it does work in Node. I expect it works now. Very good, very good, very good. And maybe we can remove this parenthesis. Yeah. Okay, great. So now we can build ops from code points directly, and that's going to be nice for doing our tests of sending something from one replica to another. So let's give that a shot. So it sends, well, it checks. Well, I don't exactly know yet what I wanted to check, but let's say we have this time alpha and beta, and we do alpha log Pinsk again, maybe, or maybe we do alpha log P, and we say append op of this time build up of alpha of empty log alpha, and the code point should be something like a code point from char, right? Code point from char p. And so now we have oh, build up, isn't that available? Should be. But I need something to test in here. Not that, sure. I don't need the in, and I do not. I didn't do block, and so yeah, I think append op takes a log, and so I need to pass it empty alpha, log alpha as well. So that's not that doesn't. Let's say pure true here or something, or maybe unit. It checks out. A node value build up. Ah, okay, of course, that's because we have this. We import everything manually, so let's just not. And it's unhappy with the return type. I think we want to return units in truth. Indeed we do. Okay, so this pattern there, we say that we append the log, but we need the log. I think that means basically state monad. That's how I'm thinking of it. And when this is wrapped in a state monad, or better, an update monad, then this won't be weird. This is basically is it like the run? Yeah, I think so. Yeah, this is the run with the initial state, and then this will query, this will get the inside the state monad, or the update monad. Okay, so that makes sense. And then what? And then we want to say, okay, oh well, actually we want to have the op. And so, well, alpha op is this. And yeah, alpha up. And that's all good. And we apply the op to our empty log. And then we imagine that we're actually shipping the op Okay, I want to write something like this, build up empty log beta, and but I want to say something about having received alpha log here, alpha up, because we're sending alpha up over the wire. So maybe I don't want to say that. Maybe I want to say beta log p is just append up of empty log beta and alpha up, and then that should be the natural way to simulate sending alpha up over the wire, right? And will that work? That's not clear. I kind of want to log show beta log p, because I'm not sure what that looks like. And let's log show alpha up as well. And that's, oh, I need to lift effect. And import log show. And it doesn't know how to show up, which is all good. So let's can we, no, we can't derive, right? So let's derive, yeah, why not? Let's derive a generic instance for up, and then we do instance show up will be show up where show equals generic show. Now we can recompile this. And it builds. And what does it show us? It shows us up alpha 2, which depends on just alpha 1 with the code point. And then log beta 1 has the code point in it. 1 infinity. Alpha 2 pointing to, okay, yeah, that's all wrong. I think that looks all wrong. Yeah, it's imagining that beta 1 is the first instance and alpha 2 the second. So there's a swapping of alphas and betas here. And then the ref links alpha 2 to alpha 1, that's correct, and beta 1 to nothing. And that should, what should, well, oh, well, no, so log at beta 1, that's fine. No, I think that's not correct. What should it be? Let's take that simple case and try to think through it with the diagrams. So we have a alpha instance with this in it. In fact, this is now infinity, right? And we haven't printed alpha log p, but let's also print alpha log p just for sanity checking. And then let's take our co-structures. And we are mapping timestamp alpha 1 to 0. Alpha 1 to, yeah, to 0, and our ref, the ref for alpha 1 is 0, and the ref at index 0 is 0. Let's see, in fact, if we want to show this more accurately, we start with I'll remove this. We start with only the empty log, which is like so. this being the root, this being the end of the weave, this being the timestamp. And then we add a alpha1 up or alpha2 up, which has as a ref alpha1 and for val p. And we therefore land with a so this is empty log alpha, and this is alpha up, and therefore this is alpha log p. Where we've relinked the linked list, and let's check this out. Or maybe I need to save this to display the alpha log p. Okay, yeah, there we go. And so alpha log p has the code point in it, right? Because in fact we don't represent that 0 in the array of code points, which is fine. We have our linked list that is 0 indexed here, right? So that's why we have the index of 0 being 1, which means this being 0 that's the proper index I, let's call it. In fact, next is 1, and then infinity is infinity. And then the timestamps are alpha 1 points to 0, alpha 1 points to 0, alpha 2 points to 1, and therefore alpha 1, alpha 2 being really what we have in the structure. So that's here. That's on timestamps. And then our ref, we have alpha 1 mapped to nothing and alpha 2 mapped to alpha 1. And so that's correct. But then when we go into beta log p, beta log p should be here beta, but this doesn't necessarily matter so much. And we can say that, right, therefore here the next is 2 beta, and that's fine. And ref, t and ref, t here is definitely beta 1. That's our empty log. But t here is alpha 2. And the ref, that's when we convert the that's where we convert the shared coordinate to the local coordinate, I think. But then Does this mean this depends on beta 1? Is that correct? I'm not so sure. I wonder whether actually we want this map to just point to a local index instead, rather than the shared index. I mean, we receive the shared, the op with the shared index, that's fine, but then maybe then when we store it, we say, how does it look like in the YouTube video? The ref, the ref is this, and it seems to be indexed with the local index, and I think that makes sense, that locally it's indexed with the local index, so that when we receive beta here on gamma, we receive beta 7 as depending on alpha 2 in the op, but then we store that as 15 depending on 2. In other words, we convert it to the local representation. That seems to make sense to me, and but then maybe it's also that 0, or in our case, maybe I should do the Pinsk example, because now I'm confused about the very beginning of things. And the fact that it seems like beta actually receives the alpha 1 operation. And what does it mean? That alpha 6 started the document? The fact that alpha 6 wrote the root, and so therefore we don't have a... it's not beta 1 here, would be alpha 1. It's an interesting thought. And it seems to be, definitely seems to be the case here. So we have this notion of basically who started the docs, and we share even the origin or root op. Okay. So it sort of means that what does it mean? In terms of how we represent beta log p. We're not creating the empty log from beta. So really saying empty log alpha would be sort of the equivalent of passing this root. Okay, so let me make a note of that. Starting with empty log alpha on beta means that alpha started the document and we send the root operation. From alpha to beta. And maybe there's a better representation for this, but for now, I guess this is okay. Except now, of course, it's not okay. So I need to rethink empty log and see if I can have a representation of empty log where I don't have the root item in it, the root operation. That might special case the append operation function. I don't want to do that. The rep here makes sense because that's the index for the current log, and it means that that's the reason why beta is 7 here, because once we've received alpha 6 we know that the next that we are in fact beta 6. Hey, you know what, is there a point in there is a point in knowing which replica we're in. Yeah, that definitely is a point. So what? I mean, do I want this 0 character in the array? Will that be helpful in any way? I wonder. Maybe we can, in fact, saying that root is an op and that it's well, it depends on which replica I was can build a root from a replica for a replica, and it would be something like op timestamp rep 1 nothing, and something like from enum 0. To enum 0. Unknown value to enum. Okay. Import to enum. And I need to type this. Oh, it's a maybe. Right. So we use the code point from blah, code point from char, and we say strings. Okay, code point. Whoopsie. Code point. Use the char from char code. It's still a maybe, yeah. Okay, so maybe just the empty char. Okay, but I think the empty char is not what we want. Is there an unsafe to enum? Oh, pure script unsafe to enum. Whoopie, what did I do? Pure script unsafe to enum. What the? So no enums. Actually, it's bounded. So we could take the minimum, can't we? Yeah. Bottom. Okay, let's try that. To enum, no, not to enum, therefore bottom, and that's it. And we need to import it. A from data bounded, indeed. Okay, that works. So I have an up. And then can I make it so that the empty log really is empty and that I so what, I'd start with 0 here? Okay, let's try this. Let's keep this for safekeeping and then say that we do start at 0 and with this, however, an empty map and even an empty NDX and an empty ref. And then now our test should fail, which is fine, but we want to double check what happens when actually, oh yeah, right, empty log alpha here. Yeah, we do get some indexing issues in the test, so that's good. Our tests are covering our asses like this. And what? And therefore we do have an op1 now, which is root, and so we start by saying that alpha log1 is equal to append op of empty log alpha and root, and this is alpha log1. Probably still gonna fail. Root of alpha. It compiles, which is all good, but I think that's what I was saying about special casing append up. And build succeeds. I think we can remove most of this. I copied all of this in. Maybe we'll keep the doc test though, because we'll want to try doc tests some other time. And indeed, we do have that index out of bounds. So that could be because of the. What is it because of? Is it because of infinity or what? I don't know. Let's look at. Let's run through this. Maybe I want to. To spy on some of that stuff. Now let's see. We have timestamp R0. We know pretty well what our ops are. Okay, let's have this nearby. So logs empty, C is empty. Next has infinity in it. And we're throwing the exception in array out of bound for ndx minus 1, which is this error. So we're trying to update the next array, which has infinity in it. And this really should be empty. And we should have a special case to add nothing when we're so what is this? Insert at cursor, but there is no such cur is the length of the local index, right? So it is 0. Maybe in this case we need to pattern match on V. to say if this is the root, then I mean, we can receive the root from elsewhere. But the V will be bottom. It's true that if this is completely empty, then we can't really say that something is pointing to even the terminal object because we don't have a thing. Okay, so let's not put infinity in there. And we run into the same exception, but for a slightly different reason. Length of C is 0. And so we want to insert and next has nothing in it, so we do want to insert at 0. This is empty now. I'm gonna have a drink. Be right back. Hey, you won. Did you hear me? I just said I'm gonna have a drink. I think I was channeling you as I was feeling you arrive. Good to see you. I'll be right back. And I'm back. All right. So, yeah, I'm just going to stream for another 10 minutes or something. I'm making it a short one today. How have you been? Good to hear. Me too. Training? Can you tell me more? Like physical training? Cool. Very nice. Like cardio or stretching or... Nice. Good basics. Okay, so I'm appending, and so this is empty. That's all good. So here I'm saying that I only increase the timestamp if this is coming from my replica, but this is wrong. This is wrong. I need to increase my timestamp even if it's not from my replica. So let's fix that. That sounds better. And then what? Then we snuck V into C. And length of the empty array should be 0, and we're inserting at 0 something in the empty array, and maybe that's not a thing. Let's see. Try pure script. Import data.array and render text and insert at of 0 in the empty of, let's say, A inside the empty array. Right, and such that if it's just A, then A, and if it's nothing, then let's say B, which is random, but unknown data. Okay, import data.maybe. Oh no, I was just gonna chill out. I think probably watch a movie. I haven't decided yet. You know, it's the evening already here. It's approaching 7 p.m. So just going to root, and it's pretty windy and nasty outside. So perfect for, you know, staying in and under the blanket and watching a movie. Cannot match our string with string. What? No, we're Sunday, right? Aren't we Sunday? Why am I being yeah, we're Sunday. It's almost Monday. I can't beat that logic. That's true. Well, I'm actually dealing with that in my code, like it's you know, off by 1 error, so you know, Monday or Sunday, it's almost the same, right? And all right, this should be a char, I believe. Yeah, you're not going to be happy with that. That's fine. Let's fine. Let's say like we're inserting, so it's like, how about this? Array int with string. Yeah, do I have string somewhere now? Oh, right. Yes, I need to show this. And I got an array with 1 in it. So it does work. Why? Right. Yes, time is relative. And it must be Monday, at least somewhere in the universe, right? If they also have a 7-day week, which would be quite the feat, given that the week is not a natural phenomenon. Okay, so I believe cur is 0. And next is empty array. So maybe I'm focusing on the wrong thing. No, index out of bound in ndx -1. So could it be that... okay, well, let's spy things. Spy cur. Debug trace, indeed. Oh, it's a bit slow, but you know, that's all good. But the good thing is now I have tests, and so when I modify something that's going to break my earlier assumptions, I know it, and that's a really important thing. And I am kind of changing now what the empty log is supposed to be like, because I realized that I thought that beta's empty log would be starting with a beta 1, but it doesn't actually. There's such a thing as saying, well, alpha 6 actually has the root, which is this 0/ thing, and then beta receives that, which means that we kind of know that alpha started the document and beta receives the start of the document together with its first synchronization. So that's something I didn't think of, and now I know, and now I'm modifying the data structure to reflect that. And trying to debug stuff. Cur is 0, so this assumption is correct. And then, well, then really, this is quite strange. Oh. Big mistake here. I copy pasted this, but this is a different data structure, and so I might actually be trying to fix the wrong one. So this is array out of bound in next. Yeah, that's right. Every replica has their own log, right? Which is this log data structure. Yeah, interpreting them means deciding what we print on screen. And so, for instance, in here, this is the log on both alpha and beta at the end of the merge there. Here, alpha 6, beta, gamma. So that's what both alpha and beta will have in their log, and this is what gamma will have in its log. And when we interpret both with my naive project function, and hopefully will be a smarter projection function in the future, we'll take that log and we render it to the same string every time, and that's the beauty of this data structure. But indeed, all our replicas have their own log, and so, as you say, their own array. Right, so if we go back now, we know that indeed it is the index -1, and I need to also fix this, which is well, to be honest, I can just delete that for now, because we will have an unsafe append, but we don't know yet what it will be. And so this is where the problem was, and we were trying to insert at cur +1 in an empty index, and so that's where it doesn't work. And it used to be that it had timestamp rep1 in it, and so maybe you should have, well, is that where we add? No, it's not where we want to add infinity. It's the ref. Let's see. Oh no, it's the next env. Yeah, it's the next env. Yeah, that's fine. I think we can say cur. I think now it's going to be indexed slightly differently because we have an additional root item in there. So let's see. Okay, well, it doesn't throw an exception anymore, so that's good. And our append up, I think when we print it out, so we don't need to spy on cur anymore. And we're saying that right, so it's telling me that those two things are different, and it makes sense that they're different because indeed they absolutely should be, because now we indeed have a code point from chart bottom in there to enum bottom. Not only that, but okay, so 1, 2, this is not right. And that's because I should special case my first insert in the next array. So we're kind of saying that let's do a nested case. It's not pretty, but we're saying case v of bottom, then that's the infinity array, and otherwise we do the case. You can't reach that case. Why not? V. Okay, so maybe we say v equals bottom of true and something else. Okay, you're happy with that. Cool, and let's see what this gives. Infinity 2. Okay, so what? It should really be cur plus 1 here, and then just cur here. And index out of bound next. What are you saying? V is not bottom? V should be bottom when I insert my initial root. Right, because root has bottom in it. Root has bottom in it. Or maybe I could also detect it with the nothing ref, I suppose. Yeah, maybe that's prettier. How about that? Oh, right, no, actually I can't do that, just in case someone else thinks they depend on the root. It's possible. No, in that case they would depend on alpha 1. So I guess I could do that. Well, you're not happy with tween and bottom there. Oh, right. No, it's not tween and bottom. It's just bottom. And index out of bound next. But you shouldn't be executing this. Or is it in the just at the second time? Then cur is 1, and so yeah, okay. It's just the second time. Makes sense now. Okay. Okay, no exception anymore. And what do we have? We have alpha 2, code point 050, and alpha 2, code point 050, and infinity 1 instead of 1 infinity. So we pass infinity. We do append the log. Cur will be 1. Okay, that's fine, but let's lift effect log show alpha log 1. And maybe I should run this in Node only without the packaging, because this delay in the feedback loop there is a bit painful. And then maybe do the browser test on commit and a commit check or something like that. Okay, so alpha 1, 0, infinity. That makes sense to me. Alpha 1, 1. so sure about that. I think it should be 0 here. And that's our NDX map. Timestamp to index. Yeah, and I'm not displaying index, but I think I should do index blah, because this is, so in that case we say it's okay. We say that when it's prefixed by index, it's in the indices of the paper. Okay, so 1 is fine. However, and alpha 1 is fine. On top of alpha 1, nothing is fine. However, then you're saying that when well, let's make sure that we're talking about the right thing here. Oh yeah, we're definitely not. Oh, are we? No, we are. But let's still display alpha log 2 and the up is alpha 2. Depends on alpha 1. Yeah, that all makes sense. Alpha 2 is infinity and then index 1. Oh, wow, so we are actually cur minus 1, that's the thing. Yeah. And I'm going to do what I said, which is I'm going to just say spago test. Oops, okay. And that should be fast, right? Yeah. No, because it doesn't have mocha. Okay, let's see, packages. Right. Huh, that's not the best, is it? It is not the best. So maybe I just comment out mocha for now. Index out of bounding next. Okay, well, that's a much faster feedback loop, so I've accomplished that at least. And then where did my code go? Index. Okay, yeah, so you're not happy with cur minus 1. After we've inserted infinity, it should be that next has length 1. So there's some problem in how this is called. So let's make sure by doing spy on cur and then spy on next. And I think I can run watch here, right? Whoopsie. next is empty here, which it shouldn't be. Okay, let's spy on ORF. And it does recompile automatically, very good. And ORF is just already has something in it. How come it should be nothing in there? Why would it not be nothing? Cur 0, I'm passing it root alpha, right? I'm supposed to be passing it 0. I mean, passing it nothing. Oh, something's fishy. Do I? Okay, maybe I should make sure that my root is root. Yep, that guy. That made you recompile the whole thing. Actually, we can also stop this for now. Okay. It doesn't even get there. So let's call this root alpha and say this and root alpha. Is this some other code that's giving me this error? And let's just comment the rest out, as well as the example. And node value alpha up. Okay, root gets nothing, and first time around cur is 0 with nothing, and then cur is 1 with ORF is just, and then next has infinity in it. And then what am I seeing afterwards? Let's just remove everything not related to alpha 1. The second cur is 0. And then you don't even get to showing the log. Is that right? Let's comment this. We're not running example, right? We commented it out, yeah. Only running tests. And yeah. So second time around, cur is still 0. Why is that? I suppose because we should, well, yeah, we should have snocked by then. And so C should be our new C. Okay, we need to spy on C. C is nothing. And then we don't even get to have a C. Can I spy on the snock here? Wow, this is getting super ugly. The snock has 0 in it. Which I think makes sense. What am I missing here? Snock has 0, but cur is still 0. And cur should be the length of C. And C should now be length 1. But I'm also thinking that I could use this I instead. I think I always want this I to be the length of C. But here my next is the next that I get past is wrong. It should have infinity in it, but it doesn't. 0. My snock seems correct. But it obviously isn't, because in the next by the way, why is this ran twice? And this shouldn't be ran twice. Unless this code is ran and I'm confused about stuff, and it could be that I need to actually, yeah, this code was ran. How the hell, why was it ran? Example. Huh. Damn. Because of the let. Is it evaluating the let? Holy moly. Could be that. So it was actually working. Oh boy. I mean, let's see if it was actually working, but this is not nice. And okay, let's print alpha log 1 and alpha log 2. And alpha log 2 has index 1 alpha in it, which infinity, which sounds reasonable. And therefore, let's now actually have our test. And pay attention, alpha 50 blah, index 1 infinity, that's correct. And then topo alpha 1 1, alpha 2 index 2. Oh, alpha 1 index 0. So we have a, oh right, yes, okay, so that's all good. We know that we should be one indexed array in the index notation here, and so therefore we pass. Okay. So now we try to see whether our naive projection still works. Yeah, there's no way it would. I mean, for instance, we need to, in fact, now. Okay, well, first of all, let's do this. And then we're really appending let's call this alpha log root, maybe, because it's not empty, it has the root in it. I like that. Alpha log root with the root, and then we use alpha log root, whoopsie, and add pinsk in it, and then alpha log pinsk should equal to, oh wait, pinsk with the backspace, yeah. And another value alpha log 1. Oh, because we're what? Oh, right, yes. Alpha log root. And and it doesn't project properly because there's a 0 now in it that we need to ignore in our naive project, which sounds all good. If it's 0, then we do what? Then we just return B, I think. Yep, that's right. So we fixed that. And then let's try with our ongoing test. But we didn't really have tests in there yet. We just needed to we needed to do the root thing. Alpha root. And then we start with alpha log root here and add p, and then also no, that's the up. Oh right, so we need to see whether build up is going to work or not. That's not sure. And then we start with alpha log root here, and then we're saying that we are indeed starting with alpha log root even in beta. So then this becomes a no, yes, that's right. So we say we have a beta log root. Which is empty log beta, but with the alpha root. When we say beta log root alpha op, which is alpha op p really here. We're appending p. Okay. And then we're printing the whole thing, including alpha op p. And it passes, but of course it passes because we haven't put any test in there. And so, but what does it look like? Up alpha up p looks like up alpha 2, just alpha 1 blah. Okay, and then beta log p. Okay, yeah, no, that sounds reasonable. Log is at beta too, but other than that, all the things are alpha things because beta hasn't started typing yet. Yeah. So now let's have beta. Well, let's write this test and then let's sort of end it here. INSK, right? INSK. We build ups for this, but we each time build it on top of the applied log. So alpha log p is this, and then alpha log pi is alpha log p and alpha log alpha up I. And alpha log pin, alpha pi with alpha up n. This is tedious, but this is fine. And then alpha log pins is alpha log pin and s. Whoopsie. Like that. And alpha log pinsk is going to be alpha log pins and k and k. And fine. And then let's just print alpha log pinsk. Alpha 5 with pins. That's wrong. I must have made a mistake. Log p, pi, pin, yeah, pins right there. Alpha 6, yeah, pinsk, okay. And now we append, so we have beta log root, yeah, and beta log p is alpha log, and alpha log pi, and beta log p. Enrolling the fold manually, why not? Pi, yeah, pin, pi, pins, pin, oh no, s, n, yeah, and k. And k. And now can print that. Alpha pi, so that'll be alpha I, pinsk, yeah, sounds good. And beta is beta 6, and it has pinsk in it. Okay, that looks fine. And so now what are we doing? Now we say beta comes into its own and appends a thing, which would be backspace, right? So backspace. And alpha up, and so that's a beta up. It's beta up backspace, and whoopsie, beta, oh well, yeah. Okay, that's definitely not what I wanted. Beta up backspace is actually, we have it somewhere. We have, yeah, this ugly thing. That's what the backspace character is, and therefore beta therefore we can build the up. Like so, saying that beta up backspace build the up on beta log pinsk with backspace. And then we print this. not very beta backspace. Oh, right, yes. Is this, oh, that's a string. Yeah, I don't need to map the singleton to it, and I can just say I want to use an unsafe version here, but I can't, so let's just say whatever, code point. Let's just say bottom actually, that's a convenient maybe value. And this. Okay, types checks. And I guess we don't need those parents. And what? And now in beta, we still have beta 6. I must have made. Right, I made a mistake. I can see it. It's right here. And right now log is at beta 7. And it has this code point 08 at the end right there. And so now we can insert beta up m and say code point from char m and have beta up beta log Minsk. Hold on. No, we can't say that. We need to give to the build up and even the backspace. That's not correct, right? We need to say where the cursor is. So the lesson is that build up in fact requires an index, not just a code point. So let's call it an int. Or maybe that's, do we want this to be a kind of a relative index? Well, I think we can leave that for next time, in fact, because I think this is a good place to stop. Build up needs a cursor position, and next time we can think about how we represent this. And let me write this down in the test as well, somewhere here, right? Build up requires a cursor position. And we can actually write this maybe as a failing test. That would be a nice thing to properly end on. And that would be something like, can we naive project, hello, naive project, beta log Minsk into should equal Minsk, but really it's going to be equal to pinsm. Or pins, in fact, not even pinsm, and that's because I need to do this right here. Oh, interesting. Beta up. Oh yeah, right, beta up M right here. And I believe we can remove these guys. And that's right, Pism is not Minsk, which is exactly what we need to fix next time. And I'm also going to be removing all of my spying things, and I'm going to commit as well, because I've been really bad with my Git discipline. So let's remove the spying. Including here and here. Okay, let me remove my partiality, and here do I have some spying left? Not that much, and I can apply or import suggestions, why not? And I can also do the same thing here. Okay. And then do I even have a GitHub repo for that? I do not. Chronofold data structure in purescript, and I should say work in progress. Boom. And this is a Git repo though, right? No, it's not. Okay, Git init then. And we do have a README, don't we? We don't. Okay. So that's a good time to make one. README.md. And I think there's a template for these things in the PureScript world. Releases and CI. I mean, we're not going to have CI yet, but let's do this. And let's say usage to be done. And for now, let's comment that out and say Chronofold data structure in PureScript, and say work in progress, and maybe plug our stream. Well, work is done in the open, and actually maybe we plug the declarative programming streams thing. I wonder. Well, yeah, we do, but we also plug our own thing, our own channel. See other declarative programming streamers. Find out about other classic programming streamers. And in the open on and archived on the YouTube channel. Here. Okay. On Twitch. And archived on YouTube. And then find out about other classic programming streamers. Chronofold data structures, Bagger install, well, there's no such thing, TBD. And module documentation, TBD. And we save, and then we preview maybe. Something like that. Right, we do have a git ignore, so that's nice. Source test, we might want to add the dist in it. Dist. And cache. The parcel stuff. Source test, blah, and the package, no package lock we need, and this run variant, I'm not gonna commit. In fact, I can delete that. That's not useful here. Okay, and yeah, let's add this all. And then let's do what? Let's commit. First commit. First commit. Yeah, that's fine. And oh, main, right? I need to do the new thing and push. Oh, right. I don't. Did I? Oh, I did. I did put my key up there, and there we go. Well, that's a little bit ugly, but that's fine. Cool, we committed. How cool is that? So we can. We haven't set up the doc tests, but we've pushed to blah. And we've done what? We've changed the representation, the empty log. presentation. And return that checklist. And well, I don't have a lot of links to share this time. I haven't really opened anything compared to yesterday, so we can keep it there. And I think that's going to be it for today. That was sweet. It's actually open source for real now. It's not just open source on stream. So that's cool. And yeah, we'll see you all tomorrow, same time, probably for a longer stream. And thanks for watching, and see you later.